Welcome back, mathematicians. In this video, we are going to do another example where we are solving an absolute value equation. In this case, we have the absolute value of x squared minus 8x plus 7 is equal to 5. And our goal first is to split this into two equations, applying the algebraic definition of absolute value. And so one of our equations is going to be x squared minus 8x plus 7 is equal to negative 5. Our second equation is going to be x squared minus 8x plus 7 is equal to positive 5. Now, it doesn't matter which one you put first or second. I only did this putting the second one to the right, so I had a little more space. So let's start with the first equation, and really the first step for each of these is the same. We need to get them both equal to 0 because what we have are quadratic equations. So we'll do this in the first equation by adding 5 to both sides, and so now we get x squared minus 8x plus 12 is equal to 0. From here, if we can factor this, that's probably the most efficient way to solving this quadratic equation. We can in this case, so the factors of x squared minus 8x plus 12 are going to be x minus 6 and x minus 2. We are now going to apply the zero product property, so we set each of these factors equal to 0, and we solve. And so the first solution will be positive 6, and the second solution will be positive 2. But now we can get potentially two more solutions from our second equation. The first step is the same. We are going to subtract 5 to both sides, again, to get it equal to 0. So we have x squared minus 8x. We have plus 2 is equal to 0. Again, if you can factor that, that is ideal and probably the most efficient way to solving that quadratic equation. But if you can't think of the factors rather quickly, I do recommend that we go ahead and use the quadratic formula. So the quadratic formula would be x is equal to, opposite of b, that's positive 8, plus or minus the square root of b squared, which is negative 8 quantity squared, minus 4 times a, which is 1, times c, which is 2, all over 2 times a, which is 1. Our goal now is to simplify the quadratic formula, the expression under the radical. So we have x is equal to 8 plus or minus the square root of 64. And 4 times 1 times 2 will be 8, all over 2. 64 minus 8 is going to be 56, so we have x is equal to 8 plus or minus the square root of 56, all over 2. Now, because 56 is not a perfect square, we can't take the square root of that value and get an exact answer. However, 56 does have a perfect square that is a factor. So it would be x is equal to 8 plus or minus the square root of 4 times the square root of 14 all over 2. Well, the square root of 4 is equal to 2, so we have x is equal to 8 plus or minus 2 times the square root of 14 all over 2. Once we've simplified the numerator as far as we can go, we should always try to reduce this fraction. And what we notice is that we have a common factor of 2 in the numerator and denominator. So let's factor out the 2 from the numerator, and that would be 4 plus or minus the square root of 14 as the other factor. And then we can reduce by that common factor of 2, giving us our other two solutions, which would be 4 plus or minus the square root of 14. So in this case, this absolute value equation has 4 real solutions: 6, 2, 4 plus the square root of 14, and 4 minus the square root of 14. All right, guys, good luck.